Okay, this video pertains to the Gaucher syndrome in CEP 650 for week 11. I'm just going to go over the genetic information and explain it as much as I think needed, and if you have questions, please let me know. So we can talk about an inherited syndrome mainly affecting Jewish European descent people at a ratio of 1 to 500. That's interesting. I don't have it, although this information pertains to me. For the general population, it's 1 in 50,000. So obviously, you can understand that the ratio for the European Jewish community or population, subpopulation, whatever you want to call it, is a result of a period of isolation. And you can even say genetic isolation in a sense, although it's more social, most likely. So marriage within the same community or small communities preserves the existence of a high ratio of the occurrence of this genetic mutation. And we talked about that. These ratios are for the most common type 1. There's several types. 4, give or take, to be exact, 3 types, and then there's what we call 3C. The C is for cardiac or cardiogenic. So we can see that for type 1, 10% of the population can be carriers, which is a lot. But once again, do not confuse that with the ratio of actually having the syndrome, which is 1 in 50,000 in the general population, or 1 in 500 in the European Jewish descent population. So we're talking about mutations to the GBA gene. We can talk about the idea of the GBA gene providing instructions for making an enzyme called beta-glucocerebrosidase. Woo, that's hard to express. If you can express that, I'm giving you an A. Not really, but you can try. And this is an enzyme that breaks down a fatty substance. When you don't have it, or the protein is dysfunctional, then you don't have a breakdown of that fatty substance, and you start storing it, accumulating it in the wrong places, in the wrong amount. So we see that the mutations greatly reduce or eliminate the activity of the enzyme. It's an autosomal recessive pattern, meaning, once again, has nothing to do with sex chromosomes, giving a natural 50-50% of inheritance or occurrence between sexes. Okay, you need 2 copies to be inherited, one from mom, one from dad, in order to have it. And that's kind of a pattern that repeats itself with the patterns of inheritance. That's why it's called a pattern of inheritance. So we see that with each pregnancy, we have 25% of having of one of the children or the offsprings for the same couple having the disease. 25 chance of being completely clear of having the disease and being a carrier, meaning that you're not a carrier and you don't have the disease, and 50% of being a carrier. We can see that carriers are usually asymptomatic. We know that there is above 300 mutations identified and related to the disease. That means that most likely the relationship, the genotype-phenotype relationship, is weak, meaning that it's hard to pinpoint what mutation causes what symptom. Mutations are affecting the gene in every mechanism possible. So all the types of mutations that you've been taught, you'll find as causes to this syndrome. And then you can see kind of in a way, part of the breakdown for the reasons. You don't have to remember how many nonsense mutations cause the syndrome. Okay, that's not the part. That's nothing that I'm going to ask about. It isn't something that I'm going to ask about. And then we see that, and I'll explain this. We have recombination events. Recombination means the connection or reconnection of genetic materials, what I call in slang shuffling. You have sequences moving and being, they're moving, they're disconnected and then reconnected in a different order. And then we see that it has a tight homologous connection with a pseudogene. Pseudogene, once again, does not really code for protein. And then we have, and that causes the chromosome to be converted or fused or duplicated in a way that causes the disease. Okay, so the major point is the recombination idea that can definitely happen with different sequences, long, short, sometimes whole genes between chromosomes and within chromosomes. So that's the first video for this syndrome, and another one to follow.